So, welcome back for another video. So, this video has been brought on by, I invented this device, let's call it, called an eco dryer. Now, two things struck me as very odd with this eco dryer. That when making it and got it fully functional and operational just to the way I wanted it, I come across two separate incidences that happened and coalesced to lead me on to another invention, let's say. So, in order to talk about that, let's just go through a couple of experiments that I tried at home. You can try these yourself. So here we have a jar of water, ordinary jar of water, and if I leave this out in the sun like it does, it condensates, it fogs up, and it constantly fogs, basically just like the atmosphere. This is what we'll be talking about. So it condensates, the droplets collect in the top of the lid, and then if I were to tap it, it rains back down into the jar again. Or I leave the lid undone and the water slowly but surely starts to evaporate. Physics, right? And this is when I happened across another experiment that if you have these side by side, now both of these water levels were the same in the beginning. Now as you can see, this one is much more emptier than this one, and there's a very particular reason for it. So this one has a layer of oil in it. So this is where it got me thinking. If you want to see this one a little bit more, I don't know if this one's any more clearer. This one has a dye in it, and also it has a layer of water in it. Now, several things struck me as odd with this experiment. So this one started to go green, and I don't know if that's an algae bloom building up in there, so I'm going to keep it and find out, and we'll find out as time progresses. Any more changes in that? See, it looks pretty clear on here, but there is a slight hue of green to this water, and both of these were done at the same time, and this one is much more clearer. I don't know side by side whether you can see it. Still looks pretty clear, but there is a slight green effect happening in here, and it's gone very murky. Now, this one evaporates and clouds up, but this one does not. So there is no way, because of the oil slick, that this water has a chance to evaporate. It doesn't. It does something very bizarre though. The oil does something very bizarre in here. So it can't evaporate into the environment, let's say. So even if I were to tap the lid, nothing drops back down because nothing evaporates. And even if I leave the lid off of this one, the water doesn't escape. It stays at the same level that it started as. Both of these started at the same level, and this one has evaporated slowly but surely. This one is not. So this is very bizarre for me. I found this very strange. So another thing that was quite bizarre in making this eco dryer was the fact that when you have this wet environment inside here, the air is really difficult to move. So if I was to put a fan in here, which I'm going to do on another video, this will be at a later date. When I put a fan in here, which if I could do on a bigger version of this I put a fan inside, and I noticed something, that when the air was very wet, damp, the air was hard to move. Another thing that I noticed, that it was impossible to heat it up. So you have lacking of heat, you have really hard air movement or air circulation. It's really hard to get the air to circulate inside this. However, when you have a dry environment such as this one, in it, you'll be like, oh, it's got water in it. Yeah, sure, but the water isn't evaporating because the oil layer is stopping it. The air moves really fast inside here. So the drier the environment, the less moisture that's in the environment, the more easier the air moves. Now, what has this got to do with my video? Well, let's take the environment, for example, and there is this thing, because humans are very greasy, we're very greasy creatures. And oils like this, well, we use moisturizer, we cook with oil, we then wash ourselves, and then this oil transfers into the water. And slowly but surely, the more population we have on the earth, the more this oil sludge sits on top of the water, the rivers, the sea, the oceans, and as it sits there, and you can make waves and all sorts of weird and wonderful stuff, you still will either get, number one, you will get a frothing effect, which makes this water go really frothy. So with the tap water and salt water in here, so you have salt water up to this level, and then the next level is salt water, and then you have this oil slick. Kinda. Now, when we wash ourselves, we wash away all of this oil, moisturizer, and different stuff. When we eat, we take our plates and we dip them in the bin, obviously, and then if we either A, put it in a dishwasher, or we wash it with using washing up liquid, the oil then slips away from this and goes down your plug hole and into the drains. Now, you already noticed that the government here in the UK especially were having a large amount of problems with these things called lard burgers, and they say, oh, baby wipes are making these lard burgers build up. And this also got me thinking, aren't lard burgers kind of a good thing in a bad way, because they're not great for drains, but if you were able to take these out and remove them, then sure as enough they're not going into the rivers, they're not going into the ocean. And why would that be a bad thing? Well, yes, global warming, the majority of this global warming is triggered by pollution, for sure. But I was trying to figure all of this out, step by step, trying to break it all down. I always find that if you've got a problem, break it up. Where you can break it up, break it up. And what you'll find is when you solve one problem and you go to apply it to something like the planet, you seem to think, oh, it's not worked. Why is this not working? Well, it's because you have several different problems, several different factors that are all mixing inside this soup, which are creating this larger problem that all of humanity is facing, such as global warming. Yes, pollution, for sure, don't get me wrong. Number two is this, oil slick. Now, if you just do a quick calculation of how many meals, if you love numbers and you're a mathematician, calculate this. This will leave you fascinated. That if there are 80 billion people on the planet, let's say 100 billion, just to clear the air. I know there's not, but let's just say there was, yes? 100 billion people on the planet. And each of you, let's say, I don't know, 80% of them are meat eaters, and predominantly that's a lot of oil. That's a lot of oil. What we use to cook it, how we cook it, the oils that come away from the food when you cook it, what we excrete as waste. Oh, very crude, but still, we have to take this in consideration. What we eat and what we waste is also an oil buildup. And it's not just that. When we take a shower and we wash away all of these oils and greases, you know yourself, if you were back in your teenage years, how oily did your face get? Wash it in the morning, and before lunchtime you'll find yourself washing it again because you have this grease buildup. Too much grease, acne, grease, well, whatever. And slowly but surely, your dishwasher, and then you've wore your clothes and your oils have transferred into the clothing. You then use your wash machine to degrease your clothes and remove dirt and different stuff. And this then starts to go down the drains. Yeah, but it's not a problem. Yeah. Now do the calculation. Every day, let's say, maybe not everyone takes a shower every day, whatever, but let's just assume that people do take showers every day. Everybody eats. How many meals do you eat a day? 3? Well, there you go. Sometimes 4. Your plates get greasy. You have cheese, it's greasy. Milk, it's grease on it. It also contains a cream, which is grease. I look at that stuff as grease. So when you start to wash all of this away, it goes down your drains and it goes into the rivers. We are putting this grease, I like to call it the oil slick, on top of the water. And this is really starting to affect our environment, global warming. It's adding to it. Well, how does it do that? Well, the same way as in this experiment. You can try this at home yourself. You'll notice it. This one will fog when you heat it. This one will not fog up. It will not condensate. And they say, well, the wind, the tornadoes and hurricanes are getting more. Yes, it would. And you'll be like, but it does rain sometimes, for sure. And this sometimes raining that we've got, less and less rain, well, let's look at it like this. When it rains, it's surface layer, yes? It falls across the roads, some of it goes down the drain, some of it sits as a slick across the roads, and the sunlight evaporates this very quickly. And that's what causes you your mist and fogginess, and it's just surface rain. It's just this little bit that the sun has been able to evaporate. And some of the rivers, yes, there are patches in this. This isn't all even across the planet. There are blobs here, there, and greater areas of this oil slick. And there are areas where there isn't any, or minimal. So the sun can penetrate some of this water and cause the evaporation. But it's not the evaporation that it used to do before humans were widespread, let's say. And this oil slick then penetrates, the sun hits it, and it can't heat anything. All it is doing is heating the top layer of the oil. One layer of oil underneath it is about this thick, heats this bit, most of it bounces off, and it causes it to move out the way. Convection in a type of sense. It heats one bit, it moves, it moves, it moves, it moves, and then there's cooler oil coming up to take the heat, and then it cools and falls down and rises and falls, and this is constantly going off, so it's never actually penetrating the water to cause this evaporation. The more humans become widespread, and let's say we get up to, just example here, 200 billion people across the planet, and this is going to impact even more oils are going to be used, even more food is going to be consumed, even more washing is going to be required. So with all of that in mind, this oil slicking, let's say, starts to cause the environment to become very, very dry. And just like this experiment that I found, there are several things that happen when the environment becomes dry. And that is air movement. You can move colossal amounts of air when it's dry. But when it's slightly damp, it's heavy. It's more heavier. You can test this yourself. Anybody live in a damp house, or ever lived in a damp house? Have you ever tried to heat your house? Never mind that. Have you ever tried to use a fan in the summertime inside a damp house? The fan just doesn't seem to blow the air at you at all. If you open the window in a damp house, all of them, and you cause a draft to come through and the fan catches that, you feel it. And you're like, how come this fan is sometimes more powerful than not? Well, when building this eco dryer, it has no element in it whatsoever. But I found that the more I dried the air, and dried the air, and dried the air, and dried the air, I put another fan inside it, the movement of the air was so much more faster. It was so fast. It was more faster than I've ever experienced a fan. Another thing I noticed was usually the fans burn out after a while. Not this one. Not these two. They haven't burnt out. Isn't that odd? Usually they're all from the same company, the same make, the same type of fan, same size, and yet the one in the house that was blowing around burnt out. Actually, I had 4 altogether. 2 that were in the house have burnt out, and the 2 that are inside this dried environment are still going. They are still going. Why is that? Well, because it's lighter air. It's not straining the motor as much. Thus for, no strain on a motor, it lasts longer. So how does this affect weather? Well, the more drier the air, think about hurricanes. Aren't they getting stronger? Think about tornadoes. Aren't they getting more stronger? Yes, because the air is dry. And you'll be like, well, I see lots of rain afterwards and it causes flooding and this, that, and the other. That's different. It's a different process going off there. So let's say that we have more frequent flooding, let's say, and it parches the land gets wet, let's say, and then the water moves away. And like I said, if you were to spill this across the land, what's going to touch the land first? The water or the oil? Well, it's clear. It's going to be the water. Because the water moves on the land, It then soaks into the land starts to soak up all of this water before it even gets to the oil slick. And then let's just say it starts to wash back out again along with the oil. You're left with this water, and this water is then easier for the sunlight to hit it and dry the land. And it's drying this, and this is evaporating, and this is what is probably calming down. It's kind of like, it's almost like the planet is trying to really heal itself by doing a different way. Now, let's take America for example. I believe it's China this side, then we have the ocean, and then we have America. Well, if we were all full of tropical rainforests, let's just say for example that the planet was more covered widespread in forests, and let's say, not blaming China here, not at all, but just need you to understand something here. Everything has an effect. And we chop down all the trees in China, where that sunlight was penetrating moist vegetation, and the more light heat was hitting the forest, the roots go down so deep they start drawing out this water, and the light hits into the leaves and it causes them to evaporate their moisture, stops them burning. Let's say you then take away all of this factor, and now you've got concrete and buildings, and the sunlight hits it, bakes it, but there's no evaporation process going on. You know, we covered the land, we sealed it. And then what happens? Well, you get this drying effect, that it all starts to dry. It's so much more dry volume of air. Well, like I said, you take a fan, get a weather system to push that now dry air, and it might catch some spray in the ocean perhaps, and then it moves across and then hits America. What do you think you get? Pleasant weather? Bit more calmer? Or do you now think that you would, the more you expand this concrete layer, the more you expand buildings, what you then end up with is drier air, more arid and drier air, then bushes, and when it reaches maybe a slightly more moister area, storm, big ones, and they're going to get bigger and bigger. Now, this is not, it's not, there is light at the end of the tunnel, because via doing this, we kind of found out another way, that there's a way that we can get around this. So I'll go on to the drawings in a second, but first of all, I just wanted to just sort of tease your minds open a little bit. Sure, we got pollution. That's not helping. That's really not helping us. Let's be realistic. So yes, that's one factor. Number two is this oil slicking. It's everywhere. It's over the rivers, it's over everything. Something else that I've discovered in with this, the algae. Hence why the methylene blue is in here. And trying to stop the algae bloom in one of them, it was pretty impressive. Algae, very strange stuff, isn't it? Should we be more alarmed when we start seeing this? So I've got one more for you. Now, I'm not saying any of these are accurate. I'm not saying any of these are right. I'm just saying, let's just have a look at this for a second. Now, mushrooms used to be renowned for growing on the forest floor. And we can take this, not just mushrooms as the example, because there's lots of them that do it. Now, on this planet, most certainly, the keys to life are moisture, water. You need it to survive. Most everything living on this planet needs water. Without it, you're a goner. Number two is oxygen. Perhaps some need carbon, some need a little bit of this. But anyway, that's another state. We've not oiled up the air. So let's say we start taking this. So we know that the forests are starting to burn and catch fire a little bit more. Well, if there's not enough moisture, and we've got this oil slick going on, and the sun that used to hit the ocean would start to evaporate the skim. So remember that. So we have salt water up to here, and then what sits on top of the salt water is fresh water, and then we've got this slick of oil. And I'm not on about oil that comes from it spilling out of wherever they have got the pipelines and are drilling for oil. I'm not on about that oil. You can see it. It's coloured. I'm on about the stuff you can't see. Baby oil type of stuff. The substances that we sweat out and we leak out of our pores, and I'm on about that type of oil. You can't see it. Look at your bath water afterwards and there's a slight scum on top. A skim of oil. basically. You'd be like, well, we use degreasers, we just shove a load of degreasers only work for so long, and then when there's more grease, the degreaser won't work. Anyone that's ever been a mechanic before, if you get your hands covered in oil and you use the degreaser, strong degreaser, clean your hands, you might need to use that substance 4 or 5 times, because once is not enough. It just doesn't get all of it off. It gets some, but not all of it. Well, if you were to leave this in the sink after you washed your hands, you will notice something, that the degreaser stops working, and you get this build-up of this oil slick again. So, when in the old days, before lots of humans were about, lots of oil was about, let's say, you would then have this ocean layer, fresh water layer, and it'd sit out on the sea. And the oceans are so vast compared to the land masses. So the sunlight would hit this water, and it'd cause it to evaporate. Thus for, it evaporates just like it does in this jar, and it evaporates and it condenses clouds, and when I press the top, it drops back into the water again. That's cycling over and over and over and over. Now you add an oil mass to it, you can't do this cycling. Think about it on the environmental scale, the planetary scale. You can't do it no more. It's not as effective. Thus for, drier, arid air is everywhere. And then, I was talking about mushrooms. Well, there's not much water in the forest because it doesn't rain as much anymore. Riverbeds start to dry out, and I say, oh, it's sinkholes. Yeah, sure, perhaps some of them are. Not all of them can be explained away by saying it's a sinkhole. It's because there's lack of this evaporation going on. And then, lack of evaporation, lack of rain. Lack of rain means drier forests. Drier forests means they burn more readily. And not only that, other life forms, such as mushroom, are then, we're not getting the moisture out of the ground anymore because the trees are drinking what they can, and the forest starts to deplete, die, and they say, oh, they're rotting. Are they? Or are they dry rot? To me, when I've been in the forests, I scout around lots of forests. I love the smell of a forest. It's great. But when I go and touch the trees and I look at the rot, it's dry rot. It's not wet rot. That's after you've had moisture there. And now it's starting to dry out. That's dry rot. Most of these trees have dry rot in them. And the mushrooms will be reading this from the ground. There's not much water here. Oh my god. Oh, it's either I'm going to sit here and die, or I'm going to try and spread myself up the tree. Why? Because the tree is the next dampest thing. So if you understand that it with a life form, it's parasitic. A mushroom, in a way, fungi, is parasitic. Anybody who has any fungal infections anywhere on your body or has ever had, I never have, but still, if you've ever had a fungal infection, it's basically parasitic. It's drawing the moisture from you. It's taking from you. And we're like, it's not. It is. It's whichever way you look at it. If you dry it out, how does it live? It doesn't. So the mushroom's way to survive is to draw the moisture out of the next moist thing that's around. If it can't get it from the ground layer, it starts taking it from the tree. And that's why they're now starting to attach themselves to trees. I don't know if you've noticed the change. I'd be really interested to know. Please let me know in the comments, because this is very, very interesting. Over the years when I was a lad, I walked through the forest back then, I noticed lots of mushrooms on the floor. Now when I do it, I'm noticing lots of mushrooms all on the trees. When did that change happen? How? You notice them starting to evade around the bottom of a tree, and they're starting to grow onto the tree. That's very bizarre to me. So it's clear that there's lack of moisture. Anyway, so moving on. It's not just mushrooms that will do this, by the way. The more drier the environment becomes, any other life form that relies on moisture will jump into the next moist object, whether that will be your lungs, whether that will be your throat, whether that's in the human body, whether that's in the animal body, whether that's mushrooms, bacteria, let's say, anything that relied on this moist environment that we did have is quite clearly panicking right now, because there's not as much moisture to keep them going. Perhaps they might jump into a host called a human or an animal and try and living them. Why? Well, that's pretty obvious. At the end of the day, I don't think anything wants to die, does it? And in its last resort, if it's no longer favourable out here, it's going to be more favourable in here, on a tree, wherever it can find it. Another thing I've noticed as well is the green staining on trees. And it looks like algae to me. Now before that, I never really saw lots of it. Now I'm seeing tons of it, and it's all up trees. I can't even touch no trees now without getting covered in green. And it's not just a little bit anymore, it's lots. I don't remember that as a kid. I would have recalled it. Yeah, some trees were greener than others, for sure. Every single tree? Every single one? I just find that bizarre again. So it leads me to believe that it's more of a drier environment. Now, it's not all doom and gloom. We can not stop this in a way, we can stop this, but we also need to stop it, and we need to deal with the problem that's happening. Because another thing that caused a drier environment would melt the ice caps quicker. The ice caps would melt a lot faster in a drier environment than a damp one. This is true, absolutely. So again, it could explain why the polar caps are melting, ice caps, let's call them. They are melting quite rapidly. And you'd be like, well, some years we get snow. Yeah, we do, don't we? That's for sure, we do. We definitely do. But is snow a result of moisture, or is snow a result of an atmosphere collapsing back down on the planet? I'm very fascinated with Pluto, and I heard some scientist, I can't remember the name. If it comes to me, I will put it in the description. But there was this particular scientist that said that Pluto, not a planet, dwarf planet, whatever, and it had 75 years, roughly, I'm going from memory here, so don't quote me word for word, but on average 77 years where it was closer to the sun, and it had an atmosphere, or a slight atmosphere. And then for 135 years, it was further away from the sun, and as it slowly moved away from the sun, the atmosphere slowly but surely started to collapse back down on the surface of Pluto. And then when it gets closer and starts heating up, the atmosphere begins to puff up again. And I think this is just an active cycle of atmospheres collapsing down because it's colder, it's winter, or the orbit might have been a bit more over here. This year it was here, so it was more closer to the sun a little bit. We're not perfect orbits. And this plays a part in whether we get snow or not due to collapsing down of the atmosphere. So when the atmosphere collapses down, we get snow. The more atmosphere has collapsed. And then again, when it moves a bit more closer to the sun, it puffs back up again. And then when it moves away, it shrinks down slightly, not all the way, but just slightly. But it's enough to cause snow. Back and forth, back and forth, back and forth. But they're just your most gases, oxygen, carbon, whatever, they're just collapsing down a little bit. So when you learn about Pluto does this in it's got a really weird orbit. It's strange, isn't it? The way it's so far away from the sun, and then it's quite close to it, and then it's quite far away, and then it's quite close to it, and this results in a puffed up atmosphere, and it starts to collapse down on the surface of Pluto, creates a snow layer, if you want to call it snow, and then when it's closer it puffs back up. So snowing? Not 100% sure about that, to be fair. So I don't know whether that's got something to do with atmospheric pressure and results of collapsing atmosphere. And then you could be like, well, what about the ice caps? Again, I think this is more fresh water is there. Yes, I think there is some salt. I'm not 100% sure of all the mathematics or the whole terminology that comes from it. But definitely, drier environment, the air moves. The wetter environment, the air does not move as much. So yeah, we're going to move on to some drawings now. So I think I've run on for a bit, trying to help if you are to understand the process here. And the drawings are what are going to help understand how we can fix this. This is quite easy to fix. It is complicated, so I broke it down into stages. So yeah, so there we go. I'm going to move on to those pictures right now, and they're in no particular order, to be fair, because I've been trying to figure out how we can do this on an industrial level and I've come up with a few ideas that we should take care of the water we waste, as well as the water, and I know there are water treatment facilities here in the UK for sure, where they treat the water before they jet it off anywhere else. However, I'm not sure this is the full answer here. So if we were to have these, the same way you have a tank of water in your house, if you were to have a wastewater tank, and we were to start extracting this oil layer away from the water we waste. And yeah, I've come up with a few ideas of how we can do it. But yeah, so as I say, I'm gonna stop the video here, and then I will move on to recording that with the pictures and put it up on YouTube. So yeah, if I'm a little bit late with my YouTube video this time, I'm definitely gonna make another one straight afterwards, different topic, just because I'm a little late. I like to keep myself in check by saying that if I am late, I make two. So there's a little challenge for me. But yeah, so we'll be going over to the drawings, but I hope you understand that I'm not saying I'm right, I'm not saying I'm wrong. I just would like some more minds to get around this subject and have a think about it, and maybe tease my mind a little bit to, have I overlooked something? Could I be overlooking something? Or is there something here? And if there is, let's have a look at it. So we're going over to some pictures, and I shall narrate the pictures. Just some rough sketches right now, nothing that I've put up professionally on a computer just yet. These are all on my website, so you can check it out there. They're in the rough freehand, I like to call it. So this is where all of the better ones come afterwards. Write these down, draw these out, and then I make the better ones after. So yeah, we're going over to the pictures now, and I shall talk more on there. So anyway, whatever you're doing, see you in a bit. Right, so here we are. So this was built for the last video. If you didn't see it, check it out, with the dome on the moon, and try to find out a way of making it hotter or cooler. And the way to make it more hotter was to remove the moisture, which relates to this video. As you can see, remove the moisture from the dome, and it would cause the temperature to rise up. The same way to cool it down would use water, and it would be pumped through here, sprinkled down, and the airflow would run in between these and then come out over the top. And this would be placed underground, and as the air comes in, down, and pushes out, this would be cooler from the water, and the water would warm up and then cool down by putting it into the ground. Now this just helps you understand the principle of what is going on here. So that's the first drawing of this. So that is how this one would cool and this one heats up. Now likewise with this one was stage one. As I said, I broke it down into bite-sized chunks. The main one was pollution and particles in the air. And what would happen is the air would come in through this pump in, hit into this air stone, and bubble into the water. And then as it pushes out, the air pushes out, comes down into this one through this pipe, and out of this air stone bubble into the water. And then so forth and so on. So I use this one with water and an oily solution, but bizarrely enough, that was to catch particles such as pollution, different types of let's say if a car drives by and you get flakes of rubber come off of the tires, this would grab it. All types of metal, dust, you name it, this will grab it. And that is what led me on to this one. Which, same sort of process, but here is a very crude drawing. Now obviously I sketch things before I put them on a computer for a better version. Now this one was meant to depict, I don't know if you can see, these are little computer screens, keyboard, mouse, computer screen, keyboard, mouse, and so on. And what would happen here would be that the air that people would breathe in and out would, it all depends. If it was heating, we would go with the flow, and if it was for cooling, we also go with the flow. So this one is for AC, but if this was AC or a heating device, it works the same way. The only thing is the airflow runs a different way. And this would be so that if they were to breathe out, and it was let's say, a cold day, so it would be heating. The air heaters would be down here in each of the corners, and the heat would rise up, warm the person, and then be extracted through here. And basically, because the heat rises, it would then come through here, bubble into the solution, bubble into an oil solution. I was meant to put like a dehumidifier in here to catch any water or moisture, and then it'd be pumped through the AC or heating device and then back out into the room. And the cooling one works in a different process. The cooling air, much like a bus, when you're on a bus, and above you, if you twist those circular devices above your head, the cold air starts to come down. Well, with the times of COVID and stuff like that, this would have, it still can help, as in it grabs any air or colds or flu, any types of cold, flu or anything like that. The cold air would come down, cool the person down, and then get sucked in through these vents here. And once it gets sucked in through the vents, which is this purple line here, it then goes into the solution here. Same device would be a pumice stone, and it would bubble through an oily solution to catch any particles. Also, I was going to put an antibacterial, antiviral water, and then it would bubble through this and the oil, and any particles would be caught in here. It would then bubble into the water solution, bubble up, and then the air would run through these pumps and then be pumped back out and go down again. So this would be so that they didn't need to go and change all of the devices that they had already had installed. They just needed to change the way it was circulated. So if anyone had a cold or anything else like that, it would probably much die inside this solution here, and all we want is the air, so it would bubble through it and then it would catch the air. And because this one is pushing air into it, so the air would be pushed in, it forces the air that's already inside the pipe out through the pumice stone, and then it forces it through this one and then out, and then it runs back through the system again. And you can do the same thing for heating, it just works in reverse. So these ones would then start taking the air the opposite way, so forget these arrows for a second. The heat would then come out of these four down here, heat the person, run up the person, and then this one would then suck it out. And it would go in reverse. These would then be connected over here. It would bubble through the solution here, and then run back through the system, and then out of the, these ones here. The heat would then come through, and you'd have your heating device this way. So the system could run both ways. That's basically why I made this one. So it led on from the first one you saw to this one, which then expanded further, which then said we could grab pollution in the same way, catch it, and we could make all of this water quite toxic in these, because obviously it would grab all of the particles out of the air. Now I've already tried this experiment at home and it worked quite successfully. I managed to lower the dust levels inside my house. Fans stopped getting clogged with all the dust particles inside it. So it was a very, 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 very good device at keeping the air clean, and asthma levels lowered a lot, and it removed a lot of toxicities out of the water, but my problem out of the air, and put it into the water. Then I needed a way of getting the toxic water extracted from the toxins, the dust, the dirt, the debris, and that's where this one comes in. And what you would have is your toxic water would go in here from, let's say, this device. So if you took the water from here, or you took the water from this one, and after a day's worth of collecting debris, or a couple of days or a week, whatever it is, it takes a while for this to get clogged up, to be honest, because of the water. Then we would need to extract the toxic water from here and turn it into a pure form of water, so that we could then discharge this and it would be safe to do so. And then what you're left with is this sort of sticky oil sludge that's left in the bottom here after it's all evaporated. And how this works, now there are two ways to do this. One is this way, where these are dehumidifiers, and they're quite low wattage, so 250, 250, 250. And what happens is the air continuously circulates around here over and over and over again, and as it does so, this evaporates, and as it evaporates, it condenses here and it drops down, and then you have your purer water inside your container here. These are the top housings that get rather warm. This warming process is a very good, your compressors, if you like, they get very warm. And if you know much about compressors, they heat a lot of stuff up. So slowly but surely, this enclosed system would start to heat up, and the water droplets would then fall and form in here. Now, this then moving on is then what got me thinking further, which was this would be where your wastewater comes from. So your shower, bath and sink, dishwasher and your sink in your kitchen. And the water would form in here, fall down. Obviously I'm going to sort these out a bit better, and it'd be divided here. One would go into here if it was okay to, the float was low enough to do that. It would then demand more water in it, and if not, it would go into a overflow tank, a backup if you like. And the tank in the middle is the purer water. And slowly but surely, this here is a wick. And likewise, if you put a wick system inside here, it would absorb the water. Another one would be to put a pumice stone in here and have it bubble the same way that you would inside the first one, which was this one. So the same way you have this bubbling and the air bubbles through it, you do the same thing with your dirty water and it would bubble through this. And by doing so, the water has to push up around the oil in a circular sort of motion so that the water jumps over the oil, and slowly but surely, I have actually put this with the lid off inside a device, and it evaporated, but it took a very, very long time to do it. Now, I did notice another way, that when I put a pumice stone in the bottom here and it bubbled the water out, it slowly but surely started to extract the water from here, actually a lot quicker than it did without it. And what it did, it left me this really thick oily sludge in the bottom here, and by doing so I was able to extract the water from here without needing to require a lot of electricity, and it left the oil behind. And the same thing would happen with this one. Now I would put a pumice stone in the bottom here and a wick system, and the air travels around here in a circulatory motion, and slowly but surely it starts to build up inside this one, and then it drops down into here, and this is pure water. I wouldn't recommend drinking it, although I don't see what the problem would be. Just probably better to let this one out. And what you would be able to get from this waste water is that once this then was dispersed into a river, the ocean, wherever, the sun would be able to evaporate this one much, much, much more readily than it would from one that had an oil slick on it. Now the thing is, I didn't get as far as how to clean the tank out afterwards, because eventually this sludge will start to build up. So that's coming on my next, the next video I do. So usually this is just a scribble for now. This is just a scribble. And when I go to put it into computer form, I will then iron out those problems there. So it's not like I've got an encyclopedia or a book or anywhere I can go to figure out how this is all going to work. I'm merely piecing this together as I go through. And once I've drawn it and it appears like this, then when I go over to drawing it on the computer, I then add in the extra pieces, the extra details. So it's not complete just yet. So far, I've managed to get to the stage of being able to remove the water from the oil and leave the oily sludge. Likewise with pollution and particles, dirt particles, that if you are able to bubble them through, I am able to extract the pollution from the water. So I'm able to catch the pollution, the particles, the very fine dust particles, all sorts of weird and wonderful stuff that is in the air. I'm able to get this and trap it into the water. And I'm also able to get the water cleaned. afterwards. So once this builds up, this becomes a very funky color, this water. Yes, it evaporates, but to stop that evaporation process requires the oil slick. So in certain aspects, if there was an oil slick here and on this one, and the air's bubbling through it, it doesn't evaporate as readily as what it would do if you didn't have it at all. Now, I know that sounds counterproductive to the video just being made, however, it does remove the pollution particles, and with this oil in here, it, when able to extract the oil back away from this water, and you're left with this resin in the bottom here. So once all of the water has been evaporated from this one, you're left with this toxic oily sediment or sludge, I like to call it, and it's very sticky, and all of the dirt and debris, this completely dries out. Once this is dried out, you're left with this oily sticky sludge in the bottom here, and that is far more easier to deal with than, so for two reasons. It's not going to go back into the environment because it's trapped in a sludge. It's not going to enter into this one because this has to evaporate in order to get through here, and then falls and forms once it condenses again. And what this does is remove a lot of this rubbish that stops this evaporation process from happening naturally in the oceans and in the rivers. So it makes it less toxic. So would this require, let's say, two types of nice lump of blue tack on there, white tack, whatever. You know, you'll have one for your toilet system to drain away all of that sewage, and that runs to those cleaning facilities that are located with your water company, and they can extract that their way. And then another piping system that discharges this fresh water that has been already taken care of inside your house with, where are we? This one. And then this water, once this has circulated through here, it's removed a lot of that rubbish from the water and it's made it purer. Once it's made it purer, it should be then safe enough to just discharge this into the rivers, and slowly but surely the sun would be able to then, if it beams down on a part of the river on its journey out to the sea, number one, it's got no pollutants in it, none whatsoever. It's got no oils in it, and this would be very good for the environment. Very good. This one here then has a less demand, and this one can take care of just cleaning sewage water, let's just say, from your toilet. So each time you flush your toilet, it would come into this one and go to the treatment centers. But at the moment, what we've got is this one and this one go into the treatment centers, and I think it's just too much for the system, and it's very expensive for them to sort this out. However, if we had this one where you used your dishwasher, your wash machine, bath water, shower water, all that sort of stuff that goes down your plug hole, this one would be pure, done inside your home. And with that being done inside your home, you would have a far healthier approach to the environment, and it would take the load off of the waste facility. So would it need an extra piping system put in place? Probably. Is that going to be expensive? Yes, but doing nothing I think is going to be far more expensive if it all goes to a treatment center. We're kind of mixing each of these. It then also limits lard burgers. So the lard burgers would then start to end up inside these tanks, which would then be discharged and taken away, and these will never react with the water. Not in the rivers, it won't go into the oceans, it won't go anywhere. All that will do is be collected, and we would have to find some way of either making this into a purpose that we can use this somehow. I don't know what, that's next stage. It takes the pressure off of here. It no longer blocks the sewers with lard burgers and all the rest of it, and it also is very good for the environment. So it's not expensive to do this. So as I state, there's two here, and they're what, 250 watts? 250 watts. It helps us be more mindful of water both of these are 250, so you're looking at a kilowatt of energy. So the water that you use, in essence, it could be safe enough to go on your garden, water your plants with. It's got no toxins in it whatsoever because you've extracted them and they will remain in the bottom here. Yes, this is going to build up. And yes, these tanks are going to need to be dealt with and changed and regularly cleaned. That's for sure. But we're not going to clean these in our sinks or taps or anywhere else. These lard burgers simply would just need to be taken, collected, and then disposed of in a safe and environmentally friendly manner in each one of these. So you have one that's a backup. So if you used an awful lot of water, which again, it helps us become more wise to the amount of water we use in a week. So these tanks are pretty big. So the same way you've got a tank that heats your water, you've also got one that's bigger enough, two of them, to treat the water that you have used from your dishwasher, your sink, your bath, your shower. So if you take a shower and you only use a minimal amount of water, you're only going to fill this by a minimal amount. If you wash your plates and you only use a small amount of water, this is only going to fill this a minimal amount. If you have an A++++ wash machine, this is only going to fill a minimal amount, and that should be more than enough for this device right here to deal with that amount of water, and it will get rid of all of the impurities and make the water pure again. So yes, okay, probably not great enough to drink, although I don't know, I've seen how pure it is and I've seen what it leaves. Oh, I'm not going to say that it needs testing first, but what I am saying is it's more of a purer way to deal with things, and it's great for the environment. It's also great for space travel as well. So if you're going to go to Mars and you only find a limited quantity of water, or you take a limited quantity of water with you, it's going to be about keeping it as healthy as possible, and this maintaining it like this. Maybe you need to filter it again and again a couple more times, I don't know. From what I did from the first result of extracting dirty water and making it clean, on the first result I saw the difference. It was visibly cleaner, completely actually. It was, you know, it was all that murky stuff. You know, if you've ever emptied out the bottom of your sink before and you've got all of that leftover water in the bottom of your sink, you know, where if it blocks up and you undo that bit at the bottom and tip it out, or if you've seen the wastewater from your wash machine, you see the color of it, and it's all murky and full of absolute yuckiness. And when you use it in one of these systems, the results visually, it's clear. This water is so clear, and it's that dirty resin that's a small amount left over inside the container that you have evaporated it from, essentially. And this is what will then help the environment, and it is safer to go into a river. It's not going to kill fish, it's not going to upset the wildlife beside the river, it's not toxic. The toxicity has remained in this tank. So yes, this will need replacing. Yes, there will be a build-up. So I'm thinking of a way to go from one tank to another tank. Once this one's full, it'll start extracting, evaporating, and this one remains empty. And while this one is completely dried out, it will be left with that resin, and then it will have another little system that moves that out of the way, and then the sludge is built up and then builds up and builds up, and then this will need to be taken away by a professional group, maybe. Is it going to be expensive? No, I don't think it is. In the beginning, everything is expensive, but I think it's going to be far more expensive if we do nothing about it. It's quite clearly, is it going to be quite a lot of insurance jobs in flooding? Is it going to be a lot of insurance jobs in tornadoes, hurricanes? Is the weather going to get more dramatic? Is it going to be more flooding because the ice caps melt? I think these need to be calculated and looked at. How much property damage, how much damage is that going to disrupt people's lives? And this small inconvenience versus the grand scale and the grand scheme of things, because when the environment gets going, it covers such a large area. But when we start to do this and we give a little bit more back, I think this one has a far more beneficial impact on humanity and the environment, and we can all walk hand in hand. So yeah, this is where I'm at so far. Not 100%. I still got to iron out a few problems, but like I said, this is just stage 2. Stage 3 will be coming, and that will be how to deal with all of this. So it's not 100% complete, but it does lead on from a lot of other projects, let's say. So, you know, the grand scheme of things, this is a large one, industrial size, to extract the... I think this would get... And the more we build this technology, the more and more easier and cheaper, and, you know, how great it could be. Because in the beginning, we might be using these devices, but the technology, the more it gets built, you know, like mobile phones get better and better and better each time, so will these. Each time they're built and purchased, each time they'll get better and better and better. And then you've got the extracting of pollution from the atmosphere. Again, everybody's breathing increases great. We could start to see a decline in asthma. I mean, that would be brilliant, wouldn't it? Everybody's general health would be great, because, well, let's clean it in here rather than in your lungs. Let's make it stick to this rather than in your lungs. That's the way I look at it anyway. So again, it has it for buildings. So in the summer and in the winter, if people get a summer cold, this is going to deal with it. If you get a winter cold, no one is sharing air. It's not a radiator that's sat over here and it's got to stream or run through the current of the office, and this person coughs and got a cold or whatever, and then this person's got it, this person might get it, this one might not, and it's then in the room. But yet, if we are dealing with it so that we go with the flow, so the heat comes out at the bottom of each person, they all share the same heat in, and all of the heat rises up, and we catch it at the top and circulate it through this system, and then it gets recharged with heat. I think this has less chance of you spreading a cold or cough onto somebody else. This just eliminates it. And the same with AC as well. To cool the room down, cold air likes to sink, so the cold air would come through the top, it falls all the way down, and then we collect it at the bottom, and it runs through the system in a cycle. And this way, it stops you from happening to... I mean, it's really expensive to change all air conditioning units and heating units. Another thing this does really well is removes dust. You know, when you see all the vents all blocked up with dust on certain things, this stops it. This stops it. It's not going through a motor, it's going into the solution first. And those dust particles, you don't need grills over here anymore, because there is going to be no dust. And if the dust does, you want the dust to get sucked into these systems, because it then gets into the water. The more water acts as a medium, it's constantly bubbling through. It's not going to clog anything. So again, it's great. Number 2 is really brilliant for space flight. For space, NASA, European Space Agency, I think, is the other one. It's brilliant for them because it helps you to start getting on the ground technologies that are able to purify water, and they use so much little power to do it. It's very easy to achieve, and it makes basically planet hopping or exploration, human exploration that is, it makes it so much more easier to come by, and we can get out into the solar system and bring back more materials that benefit humans, you know, and the world alike. We rely on it. We love it. We love our phones. We love our technology, you know. Let's go with it. So all of this starts from a really strange experiment. Again, this one was from exhaust pipes. Same process of bubbling through. And this was the beginning of all of this, to be fair, where we were able to bubble it through here and put the pollutant into the water or water-like solution. It doesn't matter what you use, and it catches all of this pollution, if you like. A fizzy sensor was the first one in the beginning. This is when I first started this many years ago. So all from this, and from the eco dryer. Another one here of trying to basically cool down the air And if this was outside in the environment, this evaporating water is good. Nice moist environment. So again, this was for the dome, inside the dome, inside, I don't know whether you're on the moon or not, and you need some cooling. These would go underground and the water would be cooled down and constantly pump the air into the cold water and cool down the environment via releasing moisture and via using the cold substance that is bubbling, the warm air is bubbling through to cool things down. So yeah, it's an hour-long video, this one, and it's pretty long. I'm still a little way there of completing this project completely. I've already completed it for the eco dryer. Brilliant, absolutely brilliant. Have this up and running inside my house. It is wonderful, and wow, it's shocking really what you can do if you just sit down, think about it, think about what you want to achieve, and break it down into bite-sized pieces. It is fantastic. This is where my heart is at. I enjoy doing all sorts of things like this. Number one, it's experimenting. Number two, I get to talk about what I'm experimenting with. Number three, it's good for health. Health benefits, yep, all there. Number four, I suppose, is asthma. Having asthma myself and trying to get rid of it without needing to rely on my inhaler. And I'm not saying that you will have a miracle change overnight, but lowering the dust particles within inside your house, lowering any type of particle inside your house, becomes trapped into the water. You know, your breathing becomes much more improved. And yeah, you for all you cleaners out there, yeah, it's great because your units are not covered in this fine dust anymore. It's dust once, maybe twice a month, whereas before it was like every other day. So just by tweaking the way you live a little bit and experimenting, this is definitely for me. So as I say, I'm going to make another video because I'm a little late with this one. So I will be making another video. If I'm ever late, I make two, make myself more busy. So yeah, as of that, I'm going to leave this one right here, and whatever you're doing, wherever you're walking and venturing out from a open lockdown, be safe, be careful, and yeah, I'll see you in the next one. Take care.